Alright, let's try another circuit analysis question. In the last video they were in series with each other. Here are three resistors that are parallel to each other. So I'm given three different R's and I'm given the total I. I can't really use Ohm's law because I don't have, all I have is the individual R's. I don't have any of the I's running through here or the V's in each one of these. I'm going to find, I think to start, I'm going to find the total R. If I was to squish these all into one super resistor. They're parallel to each other. The formula for turning them into one super resistor is this one. So it would be 1 over 20 plus 1 over 100 plus 1 over 50. I turn those all into denominators of 100. And I got 8 over 100. And then, therefore, R tote, because remember, 1 over R tote is 8 over 100, so R tote is going to be 100 over 8, which happens to be 12.5 ohms. I'm going to take this, and I'm going to go... let's find, since I have the total V and I have the total R, let's find I that leaves the battery. I0 is V0 over R tote, which is 125 over 12.5, which is 10 amps. 10 amps of current leaves the battery, goes down here, 10, 10, 10, 10, 10, and but here, split. And I need to figure out how they're going to split. So I have I0 now. Next up, let's use the shopping rule. Mom gives me $125. If I go this way, how much am I going to spend here? Mom gave me $125. I got to spend it all before I go back to her. I'm going to spend $125 here. What if I went this way through the mall? How much am I going to spend in this store? $125. What if I went this way? How much would I spend here? $125. So they're all the same because they are parallel to each other. It's one of the little trick of circuit analysis, that things that are parallel to each other would have the same potential difference drop. So what I'm going to do, I'll write it here. I'm going to write V0 has got to be equal to V1, which has got to be equal to V2, which has got to be equal to V3, which is going to be 125 volts because of the shopping rule. Yes? And I'm going to take out my red and I've got to go. So I've got I's left. The three different I's. Well, I have the three different R's and I have the three different V's. I should be able to find the three different I's using Ohm's law. So I1 is V1 over R1, which would be 125 over 20, 6.25 amps. I2 would be V2 over R2, which is 125 over 100, which is 1.25 amps. And I3 is going to be equal to V3 over R3, which is 125 over 50, which is 2.5 amps. Now, it's just as a little check here, I just want to go up. We found that the current that leaves the battery is 10 amps. That 10 amps is eventually going to split and go down three different paths. Yes? So I have 10 cars traveling down this road. That means that in total, going this way, and this way, has to also be 10 cars. And do I get that? So let's just take a look at our numbers here. If I add 6.25, 1.25, and 2.5, if I add them together, whoops, I get 10 amps, which makes me happy because that's what I know from the car rule. So I'm going to go up here to my original question, and I have found those three I's, so I found everything in the question, and I'm done.